Hi there, Mr. Sutton here, bringing you the AB Calculus 4-6 Extra Practice Number 5 solutions on graphical analysis. For this problem, we're given the graph of f prime, and we want to know on which intervals the graph of f is concave down. So f is going to be concave down wherever f prime is decreasing. We see here that f prime is decreasing on the interval from -5 to -3, and also on the interval from 1 all the way down here to 6. So therefore, f is going to be concave down on those same two intervals, which is going to give us answer choice A. For this problem, we're given the graph of f prime for the graph for f, which is given by this function here. So this is kind of interesting. They're giving us the original function and a graph of its derivative. Based off of this, we want to know on which interval the graph of f is concave up. So we actually don't need this graph here to figure this out, but it'll save us a little bit of time. If we have the graph of f prime, or we have information about f prime, to figure out where f is concave up, we just need to see where f prime is increasing. But and we can see this on the graph, that we have this interval from whatever this x value is here until 0, and also from whatever this x value is here until infinity, where f prime is clearly increasing on those spots, but we don't know what those x values are yet. So to figure out the value of those x values, we actually need to take the second derivative of this and set it equal to 0. So let's go ahead and do that. F prime then, let's start there. That's going to be 5x to the fourth minus 30x squared. And then f double prime is going to be 20x cubed minus 60x. Setting this equal to 0 and solving for critical values, we can factor out a 20x, leaving us with x squared minus 3 equals 0. And then we see that f double prime is going to equal 0 if x is either 0, or if we add 3 in square root plus or minus radical 3. So the main reason we had to do this, even though we had a graph of f prime, is we needed to figure out what these turnaround values were on the graph of f prime, and it's all these critical values for f double prime. So now that we've seen this, we can interpret that f prime is increasing on the interval from, this could only be negative radical 3, so negative radical 3 to 0, and also from positive radical 3 to infinity. So therefore, f is going to be concave up on these two intervals, which is going to give us which answer choice here? That looks like choice B. For this one, we're given the graph of f prime and a whole bunch of information. They're telling us that we have horizontal tangent lines on f prime at -6, -3, 2, and 6.3. And they kind of had to spell this out because we need to know where this graph is turning around, as you'll see in just a moment. They also said we had a vertical tangent line at x equals -4, which is kind of interesting, but ultimately isn't going to affect us on this particular problem, but it could have, depending on what they were asking for. So what they want to know is on which interval is the graph of f both decreasing and concave up. So for this, we need to know where f prime is negative and increasing. Looking at our graph, we can see that f prime has a value that's less than 0 and is increasing at the same time on the interval from -8 to -6. Also on the interval from -3 to 0, so that vertical tangent line is not affecting us at all, but that would have been a place where f prime or f double prime didn't exist anyway. F prime is fine on that though. And let's see here, we also have an interval where we are negative but increasing on 6.3 to 7, and this is where they had to spell out that this was a horizontal tangent line at 6.3. So since these properties are met on these intervals, we know that f is going to be decreasing and concave up on those same intervals. So that's going to give us answer choice D. For this problem, we're given the graph of f prime. We want to know where f is concave down. So f is going to be concave down where f prime is decreasing. F prime is decreasing on the interval from -2 to 0, and also from +2 to 4. So that means that f is going to be concave down on those two intervals. which is going to give us choice A. For this problem, we're given the graph of f of x right here. We want to know, based on that, which could be the graph of f double prime from these options below. So going from f to f double prime, the only thing you can really look at is the concavity. If we have a change in concavity for the graph of f, then that's going to be a sign change in the graph of f double prime. Looking up here in the graph of f, we start out concave down, and then it looks like we have a point of inflection somewhere in here, and we're switching to concave up somewhere after 1. So we're changing from concave down to up, which is to say f double prime is changing from negative to positive somewhere after x equals 1. Looking at our graphs, A doesn't appear to do that. We're not really crossing the x-axis for f double prime. B, we're starting concave, we're starting positive rather than negative, so that's no good. Same thing with D. Choice C here, we're going from negative to positive somewhere after x equals 1, so it's looking like choice C is our best option here. For this problem, we have 3 graphs up here. One of them is the graph of a function, one's the graph of the function's derivative, and the other's the graph of the function's second derivative. We want to know which of the following identifies the 3 graphs. So probably the easiest way to do this is look for sign changes in one graph and see if you can find another graph where you have extrema at the same spots. So for example, in graph 1, we notice that 1 is changing sign at approximately x equals 3 and 5. And we notice that graph 2 has extrema at approximately 3 and 5. And if you look at the type of extrema, we have a max at around 3, and 1 is changing sign from positive to negative there. We have a min around 5, and 1 is changing from negative to positive, so that seems to match up pretty well. So it's looking like 1 is really 2 prime. Now, looking at the graph of 2, we have a sign change there at approximately 1.5, 2.5, and 4. And if you look at graph 3, we have extrema there at approximately 1.5, 2.5, and 4. So it's looking then that 2 could be 3 prime. So then the order of this, we've got, let's see here, 2 is the derivative of 3, 1 is the derivative of 2. So it looks like 3 is going to be the original function. Since 2 is the derivative of that, 2 is going to be f prime, and since 1 is the derivative of 2, 1 would have to be f double prime. So that's going to be choice D. On this problem, we're given the function f, it's this polynomial here. We're also, interestingly enough, given the graph of f prime, and we want to know where f is concave up. So one way to do this would be to do some sign analysis on f double prime. A slightly faster way to do it, since we already have the graph of f prime, is just to see where f prime is increasing, because increasing f prime means concave up for f. And we see that f prime appears to be increasing from -1 to 0, and also from 2 to infinity. But are those the exact values? They didn't tell us that we had horizontal tangent lines on this graph at -1 and 2. Or 0. So that's where this algebraic piece comes in. In order to figure out what the exact x values are, we are going to need to find some critical values for f double prime. So let's go ahead and do that. F prime, the first derivative, is going to be, let's see here, we have 5 times 1/20th, so that's going to be 1/4 x to the 4. And then this next one will have 1/3 x to the 3rd. And then finally, this is going to be canceling out the 1/3 completely, so this is just going to be minus x squared. Taking a second derivative, we're going to have x cubed minus x squared minus 2x. And then setting this equal to 0 and solving for critical values, we can factor an x out of all of these. And then I can factor the stuff inside here, so things that multiply to -2 and add up to -1. We'll have x plus 1 and x minus 2. So we see then that we're going to have some f double prime critical values at 0, -1, and +2. which is pretty much the x values we appeared to see on the graph, but now we have confirmation. So we see that f prime is increasing from -1 to 0 then, and also from 2 to infinity. Therefore, f is concave up on those two intervals. And this is going to be choice B. For this problem, we're given the graph of f, and we want to identify the graph of f prime from these choices below. So one thing we can look at, I mean, there's a lot of different ways to go on here, but we can look at the slope of f and see how that relates to the sign of f prime. The slope of f, we are increasing, then decreasing, then increasing, then decreasing. F prime then is going to be going from positive to negative to positive to negative. So let's take a look at our graphs and see at least which ones we can eliminate based off of this. So choice A starts out negative, so we can already eliminate that one. Choice B, we're going positive, negative, positive, negative, so choice B is still in the running. Choice C, we go positive, negative, positive, negative. Choice C is still in the running, so we're down to B and C. D goes positive to negative to positive, but we don't have a negative, another negative in there. So D is actually gone. So we've eliminated two answer choices already. It's down to C and B, which are pretty similar in terms of the signs of the f prime. So now we take a look at the slope, or the direction changes of f prime, by looking at points of inflection in the original graph. So taking a look here, it appears that we have, let's see here, 1, 2, 3, maybe 4 points of inflection for f. That means that f prime is going to reverse directions 4 times, going to have 4 extrema. So taking a look here, in choice B we've got 1, 2, 3, 4 extrema. In choice C we have 1, 2 extrema. So C has too few extrema, so we can eliminate that one. And then choice B is the only one that's left, so we're going to have to pick that. On this one, we're given the graph of f prime, and we're shown that we have horizontal tangent lines at -6, -2, and also +2, which is pretty much what it looks like, but they're basically telling us that it is what it looks like in terms of those smooth turnarounds. So we want to know on which of these intervals the graph of f, which we are not given, is both decreasing and concave up. So we're basically asking on which interval is f prime going to be negative and increasing if we want f to be decreasing and concave up. So let's just look at each interval. From -8 to -6, we have f prime being, let's see here, positive between -8 and -7, which means that f is increasing for at least part of that, which goes against what they wanted in the problem. So that's a no, because we want f to be decreasing for the entire interval. Going on to the next one, -6 to -5. F prime is negative, which is good. F prime is also increasing, which is good because we want f to be concave up. So this means that f is decreasing and concave up on the interval from -6 to -5. So that's looking like it's going to be our answer, but let's just see if we can quickly eliminate the other answer choices just to confirm the kill on this one. So we've got -2 to 0 right here. F prime is positive there. So that's a deal breaker because that would make the f function increasing and we want it to be decreasing, so this is a no. And then finally, on the interval from 1 to 2, well, f prime is negative. However, it looks like f prime is also decreasing there, which means that f would be concave down rather than the concave up that they requested. So that's also a no. So then our initial hunch here, choice B, turns out to be correct. That's the one we want.